Welcome back. Today we're going to start a discussion on the concept of matter and all sorts of properties about matter. But one of the first things we have to do is put together some language for classifying matter so that when we're talking about matter, other people understand what we're talking about. The first thing is, what is matter? When we say, hey, we're going to talk about matter, we're going to classify matter, what is matter? And obviously that's different than why do things matter. But what is it? Well, it turns out matter is stuff, okay? But how do you know what's stuff versus what's not stuff? Is light matter? Light's kind of like stuff. I mean, you can see it, it's doing things, it's hitting things, it's reflecting off. Does that make it stuff? Well, it turns out there's two primary things that have us define matter. One is that it has mass. So it's got to have mass, it's got to have some weight to it in order for us to classify it as matter. And the other one is it has to take up space. It actually has to fill things. So, you've got your finger here, that's matter, it's got mass, it takes up space. So we've got that. Light, on the other hand, has neither mass nor does it take up space, and so we don't classify that as matter. So those are our two things. The next thing we're going to do is talk about language we use to classify matter. And it's fairly early on in the class and people are like, oh gosh, vocabulary. I hate vocabulary. Why do we need to learn vocabulary? Oh, and one of the things I always say is, well, compare it to your biology classes where, like an anatomy class, you're going to be stretching out the vocabulary there. We don't have a lot of vocabulary in this class, but we do have some. And there's a good purpose for it. And the purpose isn't just to torture you. The purpose isn't just to make life a little more difficult or to make everyone who talks about those things seem smarter. The purpose of classifying things, the purpose of having these separate languages is actually efficiency. We want to be able to talk to someone and say things really, really quickly that everybody understands what we're talking about. And I'll give you an example. Now, when we teach in person, this is a great example. I have a volunteer come up and they try to do this in front of the class without using any cooking terms. Describe how to cook scrambled eggs. The results are hilarious. I encourage you to try it on your family and friends. Try not to say a pan. Try not to say a stove. Try not to say a spatula or a skillet or anything like that. And it's really hard to describe how to cook scrambled eggs. It takes somebody about 2 or 3 minutes usually. And it's even better if you go up there and, as they say, crack the egg and you just go smack like that. Oh, okay. I need to crack the egg gently on the side. Okay. And then they put it into something metal and heat it up. And you just pick something random made of metal, like this pen's made of metal, and okay, put it over, pour it over the pan. It takes a long time and it's very inefficient. Whereas if we can use terms that everybody agrees upon, like a skillet and scrambling and a stove, then it's really easy to talk about how to cook scrambled eggs because we all have a common language. So that's the purpose of all this language and vocabulary that you learn in this course and in any course. It's to have a common language so that when we talk about things, we can talk about them more efficiently. So here's our language for classifying matter. There's two primary categories we're going to talk about: pure substances and mixtures. And in each of these categories, there's two subcategories. The first subcategory in pure substance is the elements. And the elements are pretty straightforward. If you can look at this thing and use one finger and point at a box on there and say, I have that, then you have an element. So if you look over on the left-hand side, we've got K over there. The fourth one down on the left-hand side, that's potassium. So if you've got a lump of potassium there, you can take one finger, point at the periodic table, say, I've got potassium. But if you have sodium chloride, that's two things, and that wouldn't count as an element, and we'll get to what that counts as in just a minute. So elements, fairly straightforward. One thing, one finger, periodic table, you've got it. Two, the next thing we have are compounds. And what's a compound? It's two or more elements combined to make one substance. Two or more elements combined to make one substance. The stereotypical example of this is H2O, right? If you want to sound smart and you want to talk about water, you say, oh, H2O. what do we have? We have two or more elements. We've got hydrogen and we have oxygen combined together to make this new thing, this new substance called water. So those are our two pure substances, elements and compounds. Now, of course, we can take elements and compounds and we can mix them together, and that's where we get mixtures. So mixtures are two or more pure substances mixed together, but not chemically bonded. We're not mixing these things to make a new chemical. We're just mixing these things to make a mixture. If I take water and I pour some sugar in it and stir it up, it dissolves, right? And that's how Starbucks exists, because sugar dissolves in water. It dissolves, but there's still sugar and there's still water. In fact, I could evaporate off the water and I'd get the sugar back. So I haven't made a new substance called sugar water. I've just mixed sugar and water together. And there's two classifications in here. We have homogeneous mixtures, which some people will say homogeneous as well. And that's where it's the same everywhere. And it's usually very difficult to separate. So my example of sugar water is a perfect example of that. I mix together the sugar and the water, I stir it up, and you can't see the sugar anymore. You just have this kind of homogeneous thing called sugar water. It's difficult to separate. It's not impossible to separate, right? Like I said, I can evaporate off the water and I can separate out the sugar and the water again. But that's a homogeneous mixture. And the other category then is a heterogeneous mixture. And I've always wondered why no one ever says heterogeneous, but they don't. They say homogeneous or homogeneous, but they say heterogeneous. A heterogeneous mixture is different in different places. I take my sugar water, I add boba to it. I add those little boba balls. Now, one spot in there, I've got these little boba balls. Another spot on there, I've got sugar water, and now I have a heterogeneous mixture. It's several things mixed together, but it's different in different places. And so these are four categories that we're going to use frequently when we talk about matter, and we're going to say, oh, we've got this homogeneous mixture, and that should tell you right away that what you have is completely the same throughout. Everything's all mixed together. If I say I've got a heterogeneous mixture, it means there's different stuff in different places, and maybe I can separate them a little bit easier. So we're going to practice next, trying to classify some of these things. So here we go. We've got an iceberg. We're going to assume it's a nice clean iceberg. There's no bird droppings or anything like that on it. So if it's this nice clean iceberg, what is it made of? It's made of H2O. Now what did I tell you? H2O is a pure substance which happens to be made of two elements, and so it's a compound. So we're going to call this a compound. When you're trying to figure out how to classify things, the first thing you want to ask yourself is it a mixture or is it a pure substance? Right? Do I have lots of different things mixed together, or do I just have one type of thing there? Here we had one type of thing, which was water. Since it's got two elements, we called it a compound. Our next example, we're going to classify the snow cone, not the cat. And we're going to classify the snow cone here. And what do we see? It is, oops, disappearing. Amazing. Okay, computer technology is great, isn't it? So we've got the snow cone here, and what is it? It's different in different places. Over here, it's orange. Over here, it's red. Over on the other places, it's purple. So we've definitely got lots of different things going on, and we've got it different in different places. The lots of different things going on, lots of things is a mixture, right? We've got the sugar water and we've got the ice. Those are different. And it's different in different places, which makes it a heterogeneous mixture. All right. Our next one, we've got just a little pile of sodium metal. Sodium metal. Well, if you look over here at the periodic table and you go 3 down on the left there, you've got Na, which is sodium. And if I'm saying all I've got there is sodium metal, that means I can take one finger. I can point to that periodic table and say, haha, I've got Na, and we're all good. And you know, it's one of those reasons that you never really want to hang out with sodium on the playground, because when you hang out with him, he just sits there and goes, na, 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 na. So this is an element. Now, elements are also classified as pure substances. So on a technical level, you could classify it as a pure substance, or you could classify it as an element. From a practical standpoint, you want to use the most specific type of classification that you can. So yes, it's a pure substance, but even better is an element, because now we know an element is a subset of pure substances, and it tells us a little bit more about it. So classifying this one, you'd classify it as an element. All right, here's your turn. How would you classify solid vanilla ice cream? Now, I'm not talking, you know, Ben and Jerry's chunky kind of stuff. I'm not talking vanilla bean. I'm just talking basic vanilla ice cream. Okay, pause video, try it out. Right, what did you come up with? Well, most ice cream that's just kind of plain is the same everywhere, but it's made of a bunch of different things. That's got the cream, which is made of a ton of different things. It's got the sugars and all these other things. And so what do we have? We have a homogeneous mixture. So that's our discussion on classification of matter. And again, it's important just so that we can talk efficiently. So when I say, hey, I've got a compound, you know immediately it's made up of 2 or more elements, and there's nothing else there. They're all bound together to make this one substance. All right, thanks so much. Bye.